Hey guys, welcome. This is 4.1. We are starting a whole new unit today, and the way I will do this is I'm going to break this up into two different parts, and that way, otherwise it is overwhelming. Okay, so give me just a moment while I adjust my camera, and let's go ahead and get started. So I'll have a part A for you, and then I'm going to do it, and then I want you to work on your assignment, and then we're going to do the part B, the other half. Otherwise, it's way too much information. So make sure you watch both videos. This is part A. Okay. All right. For part A, let's look at the warm-up. 4.1. It says, label the following as a constant, a base, or an exponent. All righty. Now, everybody knows that when you write this little part and it goes up, that is called your exponent. Okay. Do you see how this number is all by itself and there's nothing to it? The exponent would be a 1, assumed to be 1. But this here is a constant. Constant means it's always the same. A constant is a number. A 3 is always a 3. A 4 is always a 4. So if you have an exponent, then this here is called your base. Okay? You always have a base raised to an exponent. All right. Now I'm going to throw something in there. Do you see how there's not a number in front of it? If there's not a number in front of it, it's understood to be a 1. That would be your coefficient, all right? But you don't need to label that part, but just know that if you have something like this, 2 to the x, there's a number in front of it, and that's understood to be a 1. So, all right, make sure you understand that part, and there's your warm-up for 4.1. All right, let's look at our goal for today. Make sure you submit this online. Our goal for today is students will be able to identify the properties of an exponential equations. So now we're moving away from matrix. We're not covering matrix. This is all about exponents, okay? All right, so before I start, I want you guys to notice, here's your base. Your exponent goes up a little bit, and that always gives you a solution. So I just want you guys to kind of b to the e equals the s, the solution. Kind of think of that order because it's going to help you in your next unit regarding the exponent. Okay? Alrighty. By the way, when you do write an exponent, don't write it down here. This actually is 2 times x. You need to raise it up a little bit and make it small. That is an exponent. This is not an exponent, okay? Alrighty. So let's go ahead and look at some properties of an exponent. This is called exponential growth. This is called exponential decay. In an exponential growth, notice what's inside, okay? So, notice 1 plus r. Notice there's a plus. This is a growth. That's the difference in the two. And this here is a minus. All right. So if you will take a look, exponential growth is a 1 plus r raised to the x. A was that 1 I was telling you about if it's not written. And here it's a 1 minus. That's what makes it an exponential decay. So if you will remember the original formula. All right, this part right here, instead of writing 1 plus r, sometimes we use the letter b. Okay, the letter b. That's your base. So remember your problem that I gave you earlier, 2 to the x like that. Okay, there's an understood one here. That 2 is your b. All right. So remember that the original exponential formula was y equals a times b to the x. A times b to the x. That's the original equation, okay? You will notice that in these new growth and decay functions, the b value is the growth factor, if it's a plus r. Has been replaced by either 1 plus r, which is your growth, or 1 minus r, which is your decay. The growth rate r is determined as b equals 1 plus r The decay rate R is determined as B equals 1 minus R. Okay? So when you have an equation like that, so let's go ahead and write y equals your A, 1 plus or minus R, that means it's going to be plus or minus, raised to the x. The A is your beginning amount, that's the initial value, okay? The B is your 1 plus R, which is your rate, okay? And your rate is always in a percentage. Your rate is always a percentage, okay? And then it's expressed as percentage in a decimal form, and x is the number of time it has passed. So, everyone got that? So now let's kind of go over and see all this. All right. A is your beginning amount. What did you start off with? Another word for it is your initial amount. So A is your initial or your beginning amount. Okay? R is your rate. R is your rate. And it is expressed as a percentage. So if it is a growth rate of 3%, you would write this as 3 over 100, which is 0.03. Just like that. Okay? And if it's a plus right here, see that plus? That means anything that is more than 1, all right? Anything is more than 1, that is a growth. Notice the minus. This is less than 1, less than 100%. This is your decay. And keep that in mind. Right now I just want you to learn the formula. All right. And x, what is x? X is the number of time. So basically x is your time. Sometimes you'll see it written as a letter T, and that is fine too. Okay, so instead of x, they may use the letter T, which is just fine. All right, just make sure you know where it goes. So the time, where it goes, the time is the exponential. All right, so let's take a look at an example of an exponential growth. Okay, notice you have this, the graph of an exponential growth. We always read from left to right, just like you do in an English class. This is not Japanese. We don't read, or Arabic. You don't write right to left. It's always left to right. All right, let me make this a little bit bigger. There we go. Okay. Notice from left to right, this is your left, this is your right. You see how it's growing? This is an exponential growth. Okay? Look at this one. This is a logarithm. Okay? This would also be, this is an exponential growth. So as far as logarithm goes, this is also a growth. This, you can exit off. We're going to cover this in the next unit. But for now, this is a growth. All right. Now, if your graph had gone like this, and then it comes down, see how it's coming down from left to right? This here would be a decay. Okay? Left to right, it's going down. That's a decay. Left to right going up, it's a growth. And regarding your logarithm, we'll talk about this later, logarithmic equations. This is also a growth, and you'll see a decay will go like this later on. All right. So, exponential equations and logarithmic equations are inverses of each other. Basically, there are opposites, like squares and square roots. We are going to focus on exponentials for this unit. Next unit, we're going to discover the inverses of using logarithm. But right now, we're going to just focus on the exponentials. All right. Now, there's a thing called an asymptote, and I can't spell. Can you guys not see that? Okay. And the one that we are going to talk about for right now is the horizontal asymptote. And horizontals goes from left to right. And what is an asymptote? It is a line, an imaginary line that a graph approaches but never cross. Okay? So it is a line that a graph approaches but never cross. Alright, so for example, if you look up here, okay, do you see how this one goes right here? See how the graph is approaching 0, where y is 0? But it never crosses it, okay? Now look, the one for logarithm. You see this one? See how that graph is approaching y equals 1? Right here? But that graph never crosses it. So basically it's a line that you never graph below or above it. It's kind of like a wall or a floor. Think of it like a floor since it goes left and right. And here are some rules that I want you guys to write down for a little bit, okay? So add it somewhere in your notes to help you. Okay. We're going to denote it, HA. If the exponents are equal to each other, let me zoom this in a little bit. Write this somewhere in your notes. I don't care if you write it right here, okay? Write it somewhere in your notes, because you're going to be using this even more later on. Here are the rules. The rules. If your exponents are the same, the highest degree, you look at the coefficient in front of it. That's going to give you your horizontal asymptote. This one is 3 over 2, same as 1.5, okay? If your exponent is top heavy, that means your leading exponent, okay, the beginning one, the highest degree, that's called also a degree. Exponent is also called a degree. See how the 4 is bigger than 2 and it's top heavy? You will not have a horizontal asymptote. If it's bottom heavy, see how the 3 is bigger than the 2 and it's on the bottom? Your asymptote will always be y equals 0, okay? And I can't spell. We use dashes, that's called dashes, to denote a horizontal asymptote. Okay? We use dashes to denote a horizontal asymptote. Alrighty. You guys ready? Okay, let's take a look at our first one. By the way, in your notes, see this right here, the b is the same as 1 plus or minus r. Okay? And sometimes the x, you may see a t in some other formulas, but it's the same thing. Your a is your beginning amount. So, alrighty. Let's look at some examples together. And the first thing we are going to cover, okay, is this part right here. We're going to talk about the minimum, maximum, and all that later. But right now, I want you to go from here to right here. Oops, sorry. Okay? So we are going to cover your growth and decay, your domain, your range, your end behavior, left and right, your x-intercept, and your y-intercept. That is all I want you to focus on for part A. For part B, I will come back to part B video and do that part. So for right now, we are just going to cover growth or decay to the y-intercept, okay? All right, so let's take a look at our first one. Here is your first equation, right here. Let me see if I can make it a little bit clearer. Good, all right. Now I'm going to rewrite this equation. Instead of f of x, I can write y equal. Notice there's not a number in front of it, so I'm going to write y times 2 to the x. See how your a is a 1? Okay? Looking at this graph, from left to right, there's left to right, it is going up. So this is a growth. Here's another way you can look at it. This here is your b. Is your b greater than 1? And that's why it's a growth. All right. Your domain goes from left to right. So domain is always farthest left to the farthest right. Okay? You don't need to write that. I would write that so it can help you. Looking at this graph, the farthest left is negative infinity, the farthest right. This graph doesn't stop here. It keeps going to the right, to positive infinity. So we're going to write it like this. Starts at negative infinity, because I really don't know where it starts. Way over here to the left somewhere. And it's going to go all the way to positive infinity, because it doesn't stop right here. It keeps going all the way to the right. Okay? And so that's why it's negative infinity. Or you can write all real numbers. Anytime you have a negative infinity, positive infinity, it's all real numbers. Notice I use parentheses. You got to have them, because later on you're going to use bracket for certain ideas. So if you don't have that parentheses, I'm going to mark it wrong. All right. Your range goes from the bottom, like the floor, to the ceiling. Okay? The floor to the ceiling. And this is what you would write. So now let's take a look at this graph. Do you see how it kind of stops right here? You guys see that? This right here is y is equal to 0. Okay? So what is your range doing? Well, the furthest, the most bottom part, the floor, is at y is 0. Okay? It's never touching 0, but it's getting close to it. Kind of like, I'm going to touch you, but you never do. So I'm going to start at 0. The bottom is 0. How high? That's negative, but it's not going there. It's starting right here at the bottom. How high is it going? Well, here's an arrow right here. Okay, this arrow is pointing both up and to the right. To the right is your domain. Up is your range. So how far is this going? All the way to positive infinity. Okay? I'm making a video. That's okay. Thank you. I'll talk to you about this in a little bit. All right. Your end behavior. Where does your end behavior? We're going to talk about the left side of the end behavior. Okay? All right. As far as your end behavior goes, the left one always goes to negative infinity. The right one always goes to the right, positive infinity. It is your job to determine if it can go up or down. Okay? So, let's take a look. Let me get a black marker to help you with that. All right. So your end behavior. Here's your left. Left is right here. Where is this pointing to? It's pointing down. Okay? But something is keeping it from going all the way down. There's an asymptote there. So your left behavior is heading down, but it's stopping at 0. It cannot go past 0. It's only stopping at 0. The right-hand side, here's your right-hand side, okay, is heading to the right. That's why it's positive infinity. So these guys, you never change. The y is what you figure out where it goes. It's going up, and it continues to go up, so that makes it positive infinity. Okay? So far, so good? All right. Your next part, x-intercept. That means where it's crossing the x-axis. Look at your graph. Is it ever going to cross an x-axis? No, it's approaching it, but it never crossed. So that one is an NA. Okay? Your y-intercept. Your y-intercept is always this number plus the c. Your constant right here. Well, there's not a number here, so that's a 0. So 1 plus 0 is 1. So where's your y-intercept? Y-intercept is at 0, 1. Okay? So I'm crossing the y-axis at 1. And that's all I want you guys to cover for part A. We'll come back to part B in a little bit. All right, let's go ahead and do the next one. Okay? And follow along. Write these notes. That way you have an idea. I'm going to rewrite this problem. So I'm going to write y equals 1 times 0.5. And if you want to do parentheses, so you don't have so many dots, you're more than welcome to do that, raised to the x. Okay? Okay. Now remember, sometimes they put a t there. Look at this graph. Left to right, I'm going down. Notice how this is less than 1, so this is called a decay. Your domain goes from far left to far right. Remember, this one is going left and up, okay? So your domain is all real numbers. Your range goes from low to high. Now notice where it's approaching 0, but it never crosses it. So your range goes from 0, it's always the bottom going up, 0 to positive infinity. Just like that, okay? Your end behavior, remember, for the left, you always write negative infinity. For the left, negative. For the right is positive, and then it's your job to figure out which way it goes. Left side, here's your left. This is left, this is right, okay? Your left keeps going up, so it's heading toward positive infinity. Your right keeps coming down, but something's keeping it from going all the way down to here, and so that y is 0. There's your end behavior. X-intercept, never going to cross, okay? And remember, there's a plus 0 over here, so your y-intercept is 1 plus 0, so it is 0, 1. And there you have your characteristics, okay? Alrighty, let's look at another one, okay? This time, you're gonna have to come up with the equation yourself, okay? But just looking at the graph, you can tell that it is a decay, right? Your domain goes from far left to far right. Notice how it's approaching 0, but it never crosses, okay? There's my dashes, just tell me that's a horizontal asymptote. This is your horizontal asymptote. Alrighty, so your range goes from 0 up to positive infinity. Remember, negative, positive, negative, going up is positive, okay? Your end behavior, left is negative infinity for your x, positive infinity for your y, positive x for the right. Let's look at the left. Here's your left, here's the right, okay? Left is always on the left, right's always on the right. Where is that y approaching? It's going up to positive. Left, it's heading towards 0, but never crosses, okay? You have to draw that arrow. If you do not draw that arrow, I'm going to mark it wrong, because the arrow means you are approaching something. That's what you are doing. All right, your x-intercept, it's never going to cross. Your y-intercept, well, I can't tell if it's 12, 10, or 8. This is what you can do, okay? Pick a point that you see on here. That is 1, 2. Pick another point. I think it's 10. So 0, 10. Okay. So your y-intercept is 0, 10. Now let me ask you this. How would you go about writing this equation, right? Okay. There's a 1. It's a decay, okay? So I got to find the decay. So how do I find it? You're basically going to find the slope. So you're going to say 10 minus 2 divided by 0 minus 1. So 10 minus 2 is 8. 0 minus 1 is negative 1. 8 divided by negative 1 is negative 8. Okay? That's going to give you your R. There's your rate. Alrighty. Now, so it would be 1 minus, okay? That's not right. Okay. So, see, you don't even need an equation for this, but my equation's wrong. Something's not right. I'm going down by 8 over 1. Y equals your rate. 1 minus negative 8 to the x. Something is not right. I messed up somewhere. Okay, I will come back to this part in just a little bit. I don't want to tell you guys wrong, okay? But I know we have to do those 2 points. So I will come back to part B to cover that, to help you find the equation. So let me come back to that, and I want to double check, okay? Because I don't want to tell you wrong. So we'll come back to that equation in a little bit. Let's leave that box so I can show you how to find it. All right, let's go on to the next one. Key characteristics. Remember, we're only going to cover part of it for part A. Now I'm going to rewrite this one. There's a 1 in front of it, 2 to the x plus 3. All right. Looking at this graph, that's a growth. Your domain is all real numbers. Now, before you find the range, you might want to find the horizontal asymptote. 1 plus 3 is 4. So I was crossing at 4. Do you see this 3 by itself? This is your horizontal asymptote, and the y-intercept is 1 plus 3. Okay, I'll get that right. Give me just a moment. Okay, range is at 3. This is your horizontal asymptote, so your range starts at 3, going to positive infinity. In behaviors, negative infinity. To the right is positive. Figure out the y. Here's your left. It's approaching 3 but never crosses. To the right, it keeps going up. Okay? X-intercept never crosses the x-intercept. Your y-intercept is 0. 1 plus 3 is 4. And that's all I want you guys to do for right now, is these for part B. Okay? And I'll come back to part A and the one above it to help you find the equation. All right. So for right now, take a moment and just work on these guys first. Okay? And then I will do a video for part B on the minimum, maximum, interval increasing, decreasing, and the horizontal asymptote as well. All right. Good luck, guys.